Hi, today we're going to learn about go over the graphs of sine and cosine functions. So in this section, I will go over how to graph a sine and cosine graph. I will go over period, amplitude, horizontal shift, vertical shift, reflection, and how to find the four critical points. So sine graphs and cosine. So the first equation is the typical equation of a sine graph. So it's going to be y equals a sine bx. So y equals a sine parentheses bx minus c plus d. So the a represents amplitude, right? And then, so later on, you'll see that if there is no vertical shift, the amplitude will give you your maximum. We'll do more example. We will actually do some examples where there's where the amplitude is and what your maximum, because the a really does help with maximum. The bx minus c represents vertical shift. So sometimes you won't have a c, sometimes but you'll always have a b. And if there's so b is, you could just remember that it's always a number in front of x, right? So if there's no number in front of x, it's usually 1. And d is optional. Sometimes you will, sometimes you'll have a vertical shift. This is no different than like the quadratic graph. You remember quadratic, you had a vertical shift, horizontal. This is no different. In sine and cosine, you can have a vertical shift, you can have a horizontal shift, and then you can also have reflection. You can also have stretching and shrinking, right? And then period, you'll learn when you actually graph the graph, you'll have to know your period, because that'll tell you that period is usually the last point of your critical points. I'll go over the period. So basically, period is 2 pi over b. The b, as you can see, is usually the number in front of x. And then here's this cosine graph. So same thing as the sine. So it's y equals a cosine bx minus c plus d. Like I said, you're gonna have a b, you'll have an a, but the c, the horizontal shift might be optional, and then the vertical shift might be optional. Okay, so we'll go over that. So before we graph it, let's actually look at a typical sine graph. So when you graph sine graphs, it's good to know what just a regular sine graph is. So this is a typical sine graph. There's no vertical shift, there's no horizontal shift. It's just plain old sine graph. As you can see in this sine graph, this actually covers. Let's talk about the period. So how do you a period or one period or a cycle? So you're probably thinking, how do I know that graph went to one entire cycle? So how I know this is, like, you start at one point. So let's start at 0, and then it goes up, down. I mean, it goes up. That's a max. This is the midpoint, and then this is the min. And then when it starts at 0 again, so it starts at here at 0 again, that's how you know you went through one cycle. So I think it just ends at the very beginning. So from here to here is one complete cycle. Okay, so and then let's look at the max and min. So as you can see, the range, or the max, well, the max is 1, and then the min is -1. So the range is pretty much -1, 1 bracket, right? So it never goes above this, never goes below this. And how we got that is because the amplitude. So there is no number in front of sine, right? So that means there's an invisible 1. So later on, you'll see that the amplitude is absolute value 1. So that gives us your max and min. So your max is 1, and min is -1, right? And the period is just a regular sine graph, is 2 pi, because the formula for period is the formula for period is 2 pi over b. And what is our b? our b is usually the number in front of x. So as you can see, there's no numbers. That means there's a 1. So that's why our period is 2 pi. So as you can see, the 1 cycle ends up to 2 pi. So just remember, in a sine graph, just a regular typical sine graph, it starts at the origin 0, 0. And then you have a max. So this is your max. This is pi over 2, comma 1, right? That's your max. So origin, max, and then midpoint. Your midpoint is at pi comma 0. And then you have here, this point right here is your min. So it goes, so it's origin, max, midpoint, min. So the min is at what? 3 pi halves, comma is -1. And then it starts back at the origin right here. So it's at 2 pi comma 0. Okay, so you're probably thinking, how did you get these critical points? So later on, I'll talk about critical points, but find the critical points, it's just pretty, to find the critical points of the 4 main critical points is you take the period divided by 4. That's all you have to do. So what I mean is, what's our period? Our period is 2 pi. And if you divide that by 4, what do you get? You get pi over 2. Okay, so what this means, this is the part, this point right here, pi over 2, is the first point you start. So as you can see, we start at pi over 2. So you start at 0, and then your first real point is pi over 2. And then you keep on adding pi over 2. So pi over 2 plus pi over 2, you're going to get pi, right? So that's why this point here is pi. And then if you keep adding pi from pi over 2, you're going to get 3 pi halves. And then you could stop at the period, which is 2 pi, because if you add 3 pi over 2 plus pi, you get 2 pi. Okay. So that's how you find your 4 critical points. So yeah, so remember, sine graph, origin, max, midpoint, min, and then origin again. That's all. That's a typical sine graph. And I think that's it for that, the sine graph. So let's look at the cosine graph. So here's a typical cosine graph. As you can see, it's a little bit different from the sine graph. So let's write what I know about this graph. So our period, oops, this should be written as y. This is a y cosine of x graph. Okay, so the period is what? 2 pi over b. And what can you say about our b? Our b is the number in front of x, so that's 1. So that's 2 pi, right? And then what else do we know? Let's see, what's my max and min? Our max is still, well, our amplitude is absolute value of 1 because there's an invisible 1 in front of that cosine, so that's 1. So that's 1, and then negative. So what that means is our max is at 1, and our min is at -1, right? That's all it means. And we don't have a vertical shift, right? This is just regular cosine graph. And what else do we know? Our period is 2 pi, and then just like the last one, our critical points, to find the 4 critical points, you do we take the period divided by 4. So our period is 2 pi, divide that by 4, that's how you get pi halves. So that's why they started at pi halves and they keep on adding pi halves. So it's the critical points are just like the sine graph. It's going to be different if you have a horizontal shift and a vertical shift, right? So just remember, in cosine graph, unlike the sine graph, it does not start at the origin. It starts at the max at 1, right? The y value of 1. Then it goes to the midpoint. So at pi halves, it has a midpoint. And then pi is the min. So let me label this. So here, this is where we start. That's your max. So it starts at the max at 0, 1. Then you have a midpoint, an x value of pi half. comma 0. And then you have a min right here at pi comma -1. And then it starts at the midpoint again, 3 pi halves comma 0. And then it starts, this is one entire cycle, because remember, one cycle, it has to be at the same place at 1. So this is one entire cycle. I thought a cycle would be one period, but no, a cycle is just where where your endpoint is started at the beginning. So it started here again. So that's why this is one cycle. Okay. So if you if you look at this entire graph, this is actually 2 cycles because it starts here. This graph right here is actually 2 cycle. Okay, and then that's pretty much it. It's just remember in cosine graph you start at the max, midpoint, min, and then do the cycle again, midpoint, and then max, right? Now, if there was a negative in front of the cosine, this will not, like if it was like y equals negative cosine x, we'll talk about reflections. It would start here, right? But that's only if there's a reflection. Okay, so yeah, that's pretty much it. And then the range is obviously going to be bracket -1 to 1, right? Okay, let's actually start graphing some sine and cosine graphs. So in example 1 says graph y equals 2 sine x in the boundary. I wrote it in the boundary from -pi to 4 pi. So we actually have a boundary, -pi to 4 pi. So we have to follow that boundary. So it's a sine graph. So what do we know about sine graphs? It usually starts at the origin. Let's find our amplitude because that'll help us with our max and min. So our amplitude is going to be absolute value of 2. So what does that mean? Our max is at 2. And then our min is at -2. Okay, that's very important. And what else do we know? Let's find our period. Our period is, the formula for period is 2 pi over b. So what can you tell us about our b? Our b is, the b is always in front of the x, so there's no number in front of the x, so that means there's a 1. So you can rewrite this as y equals 2 sine of x, if you can read that, but yeah. See, there's no number in front of x, so there's an invisible 1. So our period is 2 pi. Okay, now let's find our critical. Is there a vertical shift? No. Is there a horizontal shift? No. Is there a reflection? No. So that's good because this graph might be easy. This graph will be easy to plot. So, okay, so now let's find our critical points. So let's find the critical points. So critical points, you start at, it's the period over 4, right? So what's my period? My period is 2 pi over 4. That reduces to pi over 2. So that is pi over 2. Okay, so that's my period. But keep in mind, we have to go to 4 pi, so it's probably at least 2 cycles. Okay, so let me draw the graph. So it should look something like this. So we first start at pi halves, right? Now, if you add pi halves with another pi halves, you can think of this as 90 and 90, so that's 180, but in radians, they're usually one in radians, so 180 in radians is pi. You can put this as pi. And then this would be what? Pi plus pi over 2. That's going to be 3 pi over 2, right? Because 180 plus 90 is 270, so 270 radians is 3 pi over 2. So I'm going to keep on going until we hit to 4 pi, because that's our boundary. So the next one is if you add 3 pi plus pi over 2, so 270 plus 90 is 2 pi, or 360. Okay, and then keep on going. So 2 pi plus what is it? 2 pi halves. So 360 plus 90, that's going to be 5 pi over 2. And then 5 pi over 2 plus another pi over 2, that's going to be 3 pi. And then 3 pi plus pi over 2 is 7 pi over 2. And then 7 pi over 2 plus pi over 2 is 4 pi. So we can stop here. And then, so our boundary is from 4 pi, so that's why I stopped at 4 pi. Now, but they say from negative, our smallest x value has to be negative pi, so negative pi would be, where would it be? So this point right here on the negative would be negative pi over 2, right? And then this would be negative pi. Okay, so what do we know about sine graphs? You go back to this sine graph, it usually starts at the origin, right? So it starts at the origin, unless there's like a horizontal shift, and then it goes to the max, midpoint, and then min again. So let's do that. So it starts at the origin here. By the way, if you didn't even know what the sine graph looked like, you could literally plug it into this equation. So this point right here is a 0 value, and x value is 0. So plug in 0, and what do you get? 2 sine of 0. 2 sine of 0 is 0, right? This is 0. So, and if you didn't know what a sine graph, you just plug in the x value. So this one, so then it goes to the max. So the max is what? 2. And then here, midpoint at pi. And then 3 pi half is the min. Okay, so this is what it should look. So it should go roughly like this. And then just keep on going, doing the cycle. Midpoint at 2 pi, and then 5 pi is at max. Okay, and then midpoint here. And then 7 pi is min. And then over here, this is origin. Okay. And then how do we figure this out? You could plug in y of negative pi halves, or you could know that in positive pi half, it has a y value positive 2, but since this is negative, this should have a negative value. So it's just probably the negative y value of that. And then negative pi, it still had a y value 0, so just leave it as 0. Okay, so this is what your final graph should look like. So if you actually know the critical point, but you forgot how to find what the sine graph looks like, and so you're trying to figure out what my y value is, just plug it into the function. So what I mean is, if you didn't know at what the y value is going to be at pi halves, just put it into the function. So y of pi over 2 is going to be 2 sine of pi over 2. And pi over 2, the sine of pi over 2 is 1. And then if you times that by 2, that's going to be 2. See? So either way works. Okay, so that was that one, example 1. Example 2. It says sketch the graph of each of the function y equals 1/2 cosine x. And it does not tell you how much period, so you can actually you can just graph one period. It didn't specifically say how many periods you should draw. So we'll just use, so you can rewrite this as 1/2. If this makes it you can write this equation as 1/2 cosine of x. So it's a cosine graph. So what do we know about cosine graphs? It starts at the max, midpoint, and then min again. So let's find our max and stuff. So what's our amplitude? The amplitude is going to be absolute value of 1/2, right? So that means it's 1/2. So that means, because we don't have a vertical shift, our max is going to be 1/2, and our min is going to be negative 1/2, right? And then let's find our period. So our period is 2 pi over b. So this applies for both sine and cosine. So period is going to be 2 pi. And what's my b? It's the number in front of x. So there's no number, so that means there's an invisible 1. So our period is 2 pi. And then let's find our critical point. So remember, if you call, it's the period over 4. So what's my period? 2 pi over 4. Simplify that, that's going to be pi over 2. Okay, so we have enough information to graph it. So well, I'm only going to draw one cycle because it doesn't say to graph 2 cycles. Okay, so what do we know? Our max is 1/2, so let's pretend this is 1/2. And then over here, this is negative 1/2. And then let's put our critical point. So our first point is at pi halves. And then you keep adding pi halves. So pi half plus pi half is what? 90 is 180. So that would be pi, right? And then pi plus 90 is 3 pi over 2. And then 3 pi over 2 plus pi over 2 is 2 pi. And we could stop at 2 pi because that's our period. Okay, so let's just follow the cosine. Remember in cosine graph, if you look for cosine graph starts at the max, midpoint, and then min. So let's do that. Oops. So at 0, this is our max, midpoint at pi over 2, and then pi is negative 1. So if you want, I can write this. So our max is at 0, 1/2. Midpoint is at pi over 2, 0, and then our min is pi, negative 1/2. Okay, so it should look like this. And then just keep on doing the cycle, midpoint, and then max again. Okay, and then this is just one cycle. Let's say your teacher specifically said to draw graph 2 cycles. So this is gonna be our negative x values. We'll use the same one, but the only difference is we're going to put a negative. So this would be negative pi half. This would be negative pi. This would be negative 3 pi over 2. And then this would be negative 2 pi, right? They're exact same x values as the positive one, but they're just negative. So with pi over 2, it had a y value of 0. So that would be, our y value would still be negative 0. So that would be 0, right? At pi, it had a y value of negative 1/2. But because we have a negative, it's going to be positive 1/2. So it'll be right here. At 3 pi halves, it had a y value of 0. So we'll just keep it at 0. And then 2 pi had a y value of positive 1/2. Since this is negative 2 pi, it's going to be the reciprocal. So it's going to be negative 1/2, right? So it should look something like this. Wait, negative pi. right? So this is negative pi half. Negative pi half had a y value of 0. That would be still be, and then negative pi had a y value of negative 1/2. So the reciprocal, so it should look something like this. Wait a minute, no, there's something wrong with this. It should actually look, you should just follow the cycle. So it should go like this, and then like that, and then like that. And if you didn't know how to do find these points, so let's just put it into the function. So what do you mean do y of negative pi over 2? That would be 1/2 cosine of negative pi over 2. So the cosine of negative pi over 2 is like going counterclockwise. So what do you mean? It's like, here's your unit circle, negative pi over 2 would be this. So the cosine of that would be, this is equivalent to saying 3 pi over 2, right? So the cosine of that would be, what is this going to be? So this is 0 comma negative 1. So that's 0. And then times by 1/2, that should still be 0. So that's why this is 0. What about pi? So y of negative pi is 1/2 cosine of negative pi. So negative pi would be right here. We're going counterclockwise. So this would have coordinate of negative 1 comma 0. So the cosine of that would be negative 1 times it by positive 1/2. So that's negative 1/2. Wait. Oh, no, I made a mistake. So it should go like this, start at the origin, and then at pi. This, and then that, and then like that. There we go. Sorry, I always make mistakes. Sometimes, not all the time, but that's how you graph it. So yeah, just follow the cycle, and then just put, I think it's just the negative, whatever these values are is negative. So this is still going to be 0. This is going to be, I still think this is going to be negative 1/2. So yeah, this is still negative 1/2. And how I found that out is like just put it into the function. And that's how I got negative 1/2. Okay. So this is only if she asks for 2 cycles. This right here is 1 cycle is good enough. Okay, so that's how you graph that one. Let's do 2b. It says graph y equals 3 cosine x. So this is a cosine graph. So, and as you can see, there's no horizontal shift and there's no vertical shift. So let's find the amplitude. The amplitude is the number in front of cosine, so that's going to be 3. So what that means is you have a max 3 and then min of negative 3, right? And then let's find our period. Our period is 2 pi over b. So it's going to be 2 pi divided by b. And what's my b? It's the number in front of x. So there's no number. So that means there's an invisible 1. So that's 2 pi. Okay, and then what else do we know? Let's find our critical points. So critical points, it's period, which is 2 pi over b. Period over 4. So that's why it's pi over 2. So that means you start at pi over 2 and then you keep on adding pi over 2. Okay, so for this one, I'm just going to graph one cycle. So what's our max? Our max is 3, 2, 3. And then my min is negative 1, 2, 3. So we start at pi over 2. And then you keep on adding until you get to 2 pi, right? So this would be pi over 90 plus 90 is 180, so that's pi. And then pi plus 90 is 3 pi over 2, or 270. And then 270 plus 90, that's 2 pi, 360, or 2 pi, right? So what do we know about cosine graphs? It starts at the max. So here at 0, it starts at your max. Your max is 3. Midpoint at pi over 2. And then at pi, that's your min. And then just keep on doing the cycle. 3 pi over 2 is the midpoint. And then 2 pi is the max. So this is one complete cycle. Okay. So that's how you graph that one for just one cycle. Okay, let's move on to example 3. The graphs y equals sine x over 2. So this is a sine graph, so you could think of it as, if you want, you can rewrite it as sine over 1/2 x. If you want, that's the same thing as x over 2. Okay, so what do we know? What's my amplitude? Amplitude is absolute value of 1, right? There's the number in front of sine is 1. So that means you have a max at 1 and you have a min of -1, right? What else do we know? We know that our period is going to be 2 pi over b. Now, what's our b? Our b is going to be not going to be 1. It's the number in front of x. So we do have a number in front of x, and that is 1/2. So we have a compound fraction. So this simplifies as, I'm going to do the bracket way, right? So over here, this 2 pi has a denominator 1. And over here we have a denominator 2. So the common denominator would be 2. So you're going to multiply 2 by 2 pi. That's 4 pi. And then you're going to multiply 2 by 1/2. That's just 1. So that means our period is 4 pi. And then let's find our critical points. So our critical point is period, which is 4 pi over 4. So that's pi. Okay, so we just found, so that means you start at pi and then you keep on adding pi until you end up to 4 pi. So we have enough information to graph it. So let's see, our max, what is our max? Is +1, and then our min is at -1, right? And then we start at our critical point pi, and then you keep adding pi until you get to 4 pi. So this would be what? 2 pi. This would be 3 pi. And then this would be 4 pi. Okay, so this would be here, pi would be here. Okay, so wait, our sine graph is you start at the origin, right? Let's go back to our sine graph, if you forget. So sine graph is you start at the origin, and then you go up to your max, midpoint, and then minimum, and then origin again. Okay, so origin would be here, then pi is your max, 2 pi is your midpoint, 3 pi is your min, and then 4 pi is your midpoint again. So this is one entire cycle. Okay, this is one entire cycle. So that's how you graph that. So I don't know if this is making it stretching or shrinking. I think it's making it skinnier. I'm not sure, but you can always put this in decimal. That's it. So yeah, so origin, your max is at pi comma 1, midpoint would be at 2 pi comma 0, min is at 3 pi comma -1, and then midpoint, origin is at 4 pi comma 0. Okay, that was that one. Now this one, example 4, is a little bit more work because we have a few things that's going on. So we have to graph this. Example 4, it's y equals 1/2 sine parentheses x minus pi over 3. So if you want, I can rewrite this as, this is equivalent to saying 1/2 sine of x minus pi over 3. So look at this graph, look at the equation. It's a sine graph. What's so special about this? It's now we have what's called a horizontal shift, right? This is like a bx minus c, right? So remember, the graph of the sine was like a sine parentheses bx minus c plus d. This bx minus c is our horizontal shift, and there's no vertical shift, right? So we have a horizontal shift, and then we have an amplitude of 1/2. So let's do our amplitude. So amplitude is going to be absolute value of 1/2. So it's 1/2. So what that means is we have a max of positive 1/2 and a min of negative 1/2. Okay, now we have a horizontal shift. I'm going to abbreviate it as HS, horizontal shift. So what you have to do is set the bx minus c to 0. So you're going to set this whole thing to 0 and then solve for x, right? So it's x minus pi over 3 equals 0, and then solve for x. So you're going to add pi over 3 to both sides. So you get x equals pi over 3. Okay, so now the first point, the critical point is going to be a little bit different. So actually, no, the phase shift is, the first point is going to be what? Pi. It's going to be slightly different. So what you're going to do to find the first point is you're going to do the phase shift plus the period. So what's my phase shift? My phase shift is positive pi over 3 plus my period. Oops, let's forget our period. Don't forget our period. So what's our period? Our period is 2 pi over b. So it's 2 pi, and then what's my b? It's the number in front of x, so it's still 1, right? So that's why our period is 2 pi. So to find the first starting point, you do the phase shift plus the period. So the phase shift is pi over 3 plus my period, which is what? 2 pi. So this is going to be 3. This is going to be 3. So this is 6 pi. 6 pi plus pi is 7 pi over 3. Pi over 3 plus pi halves. Oh, I made a mistake. It's actually, what's our critical, first, let's find our critical point. So critical point is period, which is 2 pi over 4. So that's pi over 2. Okay, so now, now I see the mistake. So to find the first point is you add the phase shift, which is pi over 3, plus the critical point, so pi over 2. So that's, no, wait, okay, so wait, let's just draw it. So this is example 4. So our max is positive 1/2. So this is, let's say this is positive 1/2. This is negative 1/2. And then our first point is actually now I remember, right? The first point is the phase shift. So you start always at the phase shift. So what's my phase shift? Pi over 3. Then you add the critical points. So I don't know why I did this. So if you add pi over 3 plus the phase shift, which is pi over 2, that's going to be 5 pi over 6. There we go. Okay, so this is what I did. So what I did is because we have a phase shift, you start at your first critical point, you start at the phase shift. So we start at pi over 3. Then you add pi over 2, that's our critical point, right? To find the critical point, you do the period over period over 4, so that's pi over 2. So what I did was I added pi over 3 plus pi over 2, that's how I got 5 pi over 6. Okay, now add 5 pi over 6 plus the critical point plus pi over 2. You should get 8 pi over 6, which reduces to 4 pi over 3. And then 4 pi. And then you keep on keep adding pi over 2. So 4 pi over 3, 4 pi over 3 plus pi over 2, you get 11 pi over 6. So 7 pi. And that's actually one cycle, because you could stop at 11 pi over 6. You don't have to stop at 2 pi, because as you'll see that this is actually one cycle, because now this one, because we have a horizontal shift, don't assume that, and remember in the sine graph you start at what do we start on sine graph you start at the origin. Now I tried doing that when I did this problem, and then I checked it using Desmo, it was wrong. So what I did is because there's a horizontal shift, just plug it into the point. So what I mean is plug in 0 into the function. So if you plug in 0, you get 1/2 sine of 0 minus pi over 3. And then that's going to be sine of negative pi over 3, which is, that could be, so if you put this in the calculator, you should get about, sine of negative pi over 3 is negative radical 3 over 2. And if you times that by 1/2, you get negative radical 3 over 4, which is about negative 4.3. So, I mean, not negative 4.3, negative 0.43. So that's very close to negative 1/2. It's not exactly negative 1/2, but it's very close. So this first point would be right here. And then when you plug in pi over 3, you should get a y value 0, or it just slowly increases. And then 5 pi over 6, when you plug in 5 pi over 6, you get a y value positive 1/2. And then just do the cycle again. So 4 pi over 3, it goes at the midpoint. And then 11 pi over 6 actually goes to the actual minimum, which is at negative 1/2, not negative 0.433. Okay, so here you start at negative 0.433, midpoint, max, midpoint, and then the min. So now this is one cycle. Okay, that was that one. Let's see how many more we have. We have 2 more examples. So example 5 says graph y equals negative 3 cosine parentheses 2 pi over x plus 4 pi. Okay, so this is a parenthesis right here. So what's happening here? So this -3 means there's a reflection. And then this 2 pi x plus 4 pi, what does that mean? There's probably a horizontal shift. And yeah, that's it. So amplitude is going to be absolute value of -3, which is 3. And so what that means is our max is going to be at 3, and then our min is going to be -3. Now let's find our phase shift. So you set this 2 pi x plus 4 pi, set it to 0, and then solve for x. So I'm going to abbreviate it as PS as phase shift. So it's 2 pi x plus 4 pi equals 0, and then solve for x. So subtract 4 pi. So that's 2 pi x equals -4 pi. Divide this by 2 pi. This would be -2 pi. -4 pi over 2 is -2 pi. So what does that mean? Oops, it's not -2 pi, the pi's cancels. So it's -2. Okay, so that's our phase shift. So that means that's our first starting point. And then let's find our critical points. So our critical points is, what is it? It's first let's find our period. So our period is going to be what? 2 pi over b. And what is my b? It's 2 pi divided by b. What's my b? It's the number in front of x. So this technically is your b, this 2 pi. So 2 pi over 2 pi is 1. So my period is 1. So your critical point is going to be the period over 4. So what's my period? 1. Divide that by 4. So that's 1. It's going to be 1/4, I think. Yeah, critical point is 1/4. So what does that mean is once you start at -2, and then you keep on adding 1/4. So this is what it should look like. It's very squished. So I'm not even going to do the positive side because I think all our one cycle is all on the negative side. So our max is +3, so 1, 2, 3. And then our min is at -1, 2, 3. Okay, so let's start at our phase shift. What was our phase shift? It's at -2. So let's call this -1. And then I'm going to put a kind of a huge space in between -2 because these numbers are very small. We're dealing with smaller numbers. So, okay, so that was -2. So what would this point be? The one next to -2. So you start at -2 and then you add the critical point 1/4. So -2 plus 1/4 is -7/4, which is technically -1.75. Right? So right here, this would be -7/4. So then you do -7/4 plus the period, which is 1/4, right? So -7/4 plus 1/4 is -6/4, which is -3/2. So this point right here would be -3/2. And then, because I think we needed about 4 points. So then do -3/2 plus my period. -3/2 plus 1/4 is going to be -5/4. So right here, this is -5/4. And then if you add -5/4 plus 1/4, you will get -4/4. which is -1. So it'll be right here. Okay, so what are we dealing on? We're dealing with cosine graphs. So what do we know about cosine graphs? It starts at the max, right? So it starts at the max and then goes down. But the thing is, what do we have? We have a negative in front of the cosine. We have a reflection. So over here, -2. Usually you would, if it was a positive, if this was a positive radical 3, you would have a y value of +3 because it starts at the max. But the thing is, there's a negative, so there's a reflection. So the y, it starts at the min, so it's going to be at -3. And if you didn't even know that, you could literally plug it in, right? You could plug in -2 into the function, and you would still get a negative. You would get an output of -3. So I don't want to do that because I already know what I already checked it in Desmo, so that's how it is. So okay, so usually if it was positive, if it was +3, it would have a max of 3. That's what you usually start, but because there's a minus, you put it, it's going to be -3, and then you start at the midpoint. So this is your midpoint, right? So you start at the midpoint, and then you're going to have a max. What was our max? So -3/2 is our max, so it's at +3. And then this one, just completely do the cycle again. So midpoint, and then at -1, this is at the min. So this, if you want, I can write the point. So this is -2, -3. This is -7/4, 0. This is going to be -3/2, 3. This is -5/4, 0. And then this point here is going to be -1, -3. Okay, so that's how you do that. So it's going to be like this. This is what your graph is going to look like. Okay, so this is just one cycle, and I'm not going to draw 2 cycles. So this one is, they had a reflection, and then this had a horizontal shift of -2. Okay, now let's do, I think this is our last one. So we have y = 3 cosine 2x. There's a little parentheses here, +2. So let's first find our amplitude. Our amplitude is going to be at absolute value 3. So what that means is you have a max of 3, and then you have a min of -3. And then what else do we know? Let's find our period. Our period is 2 pi over b. What's my b? It's the number in front of x, so our b is going to be 2. So it's 2 pi over 2. That's pi. And then this +2, what does this +2 mean? That is called, so that's called our vertical shift, right? So we have a VS, vertical shift of +2. So this this 2 changes our max and min. So this is not our max and min. So what's our max? Our max is going to be the absolute value. So remember, absolute value 3, you get 3 and -3. So the max is going to be 3 plus 2 plus our vertical shift, which is 2. So our max is at 5. And then our min is, remember, you're going to take the smaller absolute value, so -3, plus the vertical shift, which is 2. So -3 plus 2 is -1. Okay, so that was that. And then our period is 2 pi. And then I think we have enough information. So our max is at 5 and our min is at -1. And it looks like there's no horizontal shift. Oh, forgot our critical points. So critical points. So it's our period, which is pi divided by 4. So it's pi over 4, right? So our first point is pi over 4, and then you keep on adding pi over 4. So 45 plus 45 is 90, so that's pi over 2. And then 90 plus 45 is 3 pi over 4. And then 3 pi over 4 plus pi over 4 is pi. So our max is at 5. So 1, 2, 3, 4, 5. Here's positive 5. And then our min is at negative 1. Okay, so what do we know about cosine graphs? Since there's no reflection, it starts at the max. So here at the 0, it starts at the max at 5, and then midpoint at pi over 4. And then the min at pi halves, right? Then do the cycle again. So 3 pi fourths would be at the origin, midpoint, and then pi is at the max. Okay, so this is what it should look like. So this is one cycle. So if you wanted to label this point, this is 0, 5. This is going to be pi fourth, 0. This is going to be pi half, 0. This point here is going to be 3 pi fourth, 0. Then this is going to be pi, 5. Okay. So I guess that wraps up for this section.